Blockchain is the future, and if you've got even a passing interest in cryptocurrencies, you'll know just how much the word blockchain gets bandied around. But beyond knowing that blockchain is kind of a big deal, it's a pretty confusing concept for most of us to wrap our heads around. So in this video, I'm going to explain exactly what blockchain is and how it can be applied in the real world. So before we dive into what blockchain actually is, let's first take a quick look at the problem that it tries to solve. Now, originally the idea of a blockchain was first proposed in a research paper in 1991, but it took almost 2 decades more before it had its first real-world application with the launch of Bitcoin, the first cryptocurrency, in January 2009 by Satoshi Nakamoto, which tried to solve the problem with the existing banking system. The general problem here was twofold. Firstly, banks and card associations like Visa were, and still are, I guess, imposing a lot of fees on the end user, like you and me, for, buying something or sending money somewhere in order to account for fraudulent activity, to maintain security, and just to kind of generally cover their own expenses. Second, as Satoshi wrote in a blog post, the root problem with conventional currency is all the trust required to make it work. So basically, whenever we leave our money in a bank account, we're essentially trusting the central government not to screw up. But as we've seen from countless examples in history, the central government always seems to screw up in some way or another, like with the 2008 financial crisis. There's really not much need for me to go into more detail here. The point is that blockchain enables us to do a bunch of things without the need for us to trust any sort of central authority. So in the case of cryptocurrency, that means we have a way of transferring money to another person without any central bank or any other third party to get in the way or screw things up or sort of making that process more expensive than it needs to be. Now, this all sounds great, but the difficult thing for most people to wrap their heads around is what the hell this blockchain thing actually is and how it works in practice. Now, the simple and short definition of blockchain technology can be summarized as a system of decentralized digital public ledgers that stores data or transactions, in the case of cryptocurrency, secured using cryptography. Now, this probably isn't very helpful as a definition, it's hella confusing. So what we're going to do now is we're going to break down this definition and make blockchain a really clear and easy concept to understand. Firstly, it's decentralized. Now, when we buy something with our bank cards, our good old trusty bank cards that we get from our wallets, there's a lot happening behind the scenes. Essentially, these transactions are facilitated using a few centralized third parties, such as banks and payment processors, to ensure that we've got enough funds in our bank and there's no fraud taking place. So there's these really powerful middlemen essentially ensuring these transactions can happen and they can take place and all our funds are moving in the right direction. But with something like Bitcoin, there's no central location where everything is maintained and administered. So instead of having a singular central database that holds and verifies all the transactions taking place, with blockchain, you have multiple copies of the same database spread around multiple computers, or nodes as we call them, on the same network, spread out across the globe. So whenever anyone sends any amount of Bitcoin to someone else, that transaction is transmitted to and recorded by a whole network of computers spread out across the world. And if proven to be valid, the records of those transactions cannot be altered, deleted, or destroyed. In other words, they're permanently recorded on a digital public ledger which shows every single previous transaction that's ever happened. This leads us on nicely to the second part of our definition of a blockchain, which is that it's a digital public ledger. With blockchain, this digital ledger of all previous transactions is described as a chain made up of individual blocks of data. But what does this really mean? So whereas a typical database would store and structure transaction data into this sort of huge table, with blockchain, as the name describes, it instead structures the data into individual chunks or blocks. And in practice, this is what this looks like. First, all the computers on the network, the nodes, validate the transaction to ensure that there's no fraud, nobody's double spent their money, and things like that. Once validated, a specialized node or a computer called a miner is responsible for confirming and completing the transaction. Now, the process of mining kind of falls out the scope of this video, but the idea is that instead of confirming completing each transaction one by one as you would have in a table database, what the blockchain does is essentially, and what the miners do, is they bring and batch transactions together, so a whole group of transactions into a single block, and then they confirm all of those transactions in one go. Finally, once the block has enough data or enough transactions have occurred, that block is closed, it's sort of confirmed, and then it's linked to the previous block of data that was confirmed by another miner on the network, forming a chain of these different blocks of data called the blockchain. And sort of as a side note to all of this, the miner that actually gets to add their block to the blockchain is done through this process of getting these people to solve a complex mathematical problem to prove that the transaction is valid. So the first miner that can prove the transaction is valid by solving this complex mathematical problem is the accepted truth by the network, and their block will be added. And they're rewarded for this through various different means. So in the case of Bitcoin, they will be given some Bitcoin as a result of solving that problem. And this process is called proof of work. So any new information or data or transactions that happen after or follow that freshly, newly added block will then be compiled into a new block, which will only be added to the blockchain once that new block has enough data for it to be added. At this point, the entire network has witnessed the transaction being sent from one user to another, it's been validated by each node, and it's also been confirmed by the miner. So now final settlement has been achieved, and essentially the funds are irreversibly sent from the sender to the receiver. Final piece of the blockchain definition is cryptography, and this is kind of what makes blockchain so great, because it means the data is super secure and there's also no need for any third party to maintain its security. And this is all kind of down to two things. Number one, each user has a copy of the ledger, and two, the data within the blocks is encrypted using a complex cryptographic algorithm. So first, each user has a copy of the ledger. Now, all this means is that all the transactions on the blockchain are approved by a network of thousands of computers. So if there were a computational mistake about the amount of Bitcoin that I held, this would be cast away as illegitimate if all the other computers on the network didn't agree with the amount of Bitcoin that that one wrong computer stated about the amount of Bitcoin that I held. And the only way that the mistake could spread around the whole blockchain and be agreed as part of the blockchain is if more than 50% of the computers on the network agreed that I held a certain amount of Bitcoin. And this is nearly impossible on a growing and large network like that of Bitcoin's own blockchain. The second really powerful thing about blockchain security is in its use of cryptographic algorithms, which is also why we call them cryptocurrencies. Now, this is literally a whole video in itself, but the essence of this is that it's cryptography that allows us to make trustless, secure, anonymous payments to other people without having to use some sort of intermediary like a bank or PayPal to make that happen. In short, the Bitcoin network, for example, issues all users a private key, which is essentially a really strong password, and then it cryptographically generates a linked public key from that private key using a very complex algorithm. So your public key is essentially like your address that users can use to send you money. So if a friend wants to send you some Bitcoin, you'll give them your public key. Your private key, on the other hand, is something that you're going to want to keep secret, because this is how you access your money and spend it. Similarly to how you would want to keep your email and password secret, because if someone had access to your password, they could access your email account and start sending emails in your name. Now, I think this kind of all summarizes what cryptography is quite nicely. I'm going to kind of save the rest of it for another video because I could go into so much detail. But I'm hoping that this sort of captures the essence of what the blockchain is and how cryptography helps to keep everything safe and secure. To be honest, the incredible power of blockchain goes even further than this, and I've only really scratched the surface. You know, it's been tested as a secure store of patients' medical records, as a potential solution for electoral voter fraud, and also as a pretty reliable means of tracking the movement and safety of food within the supply chain. I really strongly believe that blockchain is 100% here to stay.